So we're going to start taking a look at this probability and statistics review. So this first problem, there's 40 students in a theater class, 11 take dance, 14 take voice, and 15 take neither. Create a tree diagram to represent this. Venn diagram, excuse me. So let's see. We have our dance and our voice. 40 students in the theater, so we don't know how many are in both. So this would be 40 minus x. Then 14, whoops, I think I put that in the wrong one. 11 take dance, my bad, so this would be 11 minus x. 14 take voice, so 14 minus x. And 15 take neither. So our grand total is 40. So we could write the equation here. We could say 11 minus x plus 14 minus x plus 15 equals 40. So let's see, we have 25, 35. Oh, and I'm sorry, we were supposed to change this. This is supposed to be 20, take neither. My bad. So we should have a 20 on the outside here. So that's going to switch this here. I'm sorry about that, guys. 20. So we have 25. So we have 45 minus x equals 40. So x equals 5. So we have 5, 9, and 6. So find the dance and voice. That would be 5 out of the 40. And P of V given D. So again, according to our definition, this is voice and not dance divided by the probability of not dance. So the probability of not dance would be 29. And the probability of voice and not dance, so that would be this number right there. So we have 9 out of 29. The second one here, for events C and D, it's known the probability of C is 0.7, not C and not D is 0.25, and the probability of D is 0.2. Okay, so once again, I'm going to draw this tree diagram. So we have C and D. We know not those is 0.25. Once again, we don't know our overlap, so we can put x. P of C, so 0.7 minus x. P of D would be 0.2 minus x. If we add these all together, it has to equal 1. So let's see if I can just 0.7, 0.9, so 1.15. Then we'd have minus x. So x equals 0.15. So we could put that now. Let's see if we go back here. So this is 0.15 in the middle, 0.05, and 0.55. And then the probability of C and not D. So it has to be both. So C and not D would be right there. So that's going to be the 0.55. And explain why P and C are not independent events. Well, to be independent, the probability of, for independent, the probability of C and D equals the probability of C times the probability of D. So the probability of C and D we know is 0.15, and that's not equal to 0.7 times 0.2. So therefore they're not independent. Two events occur such that probability of A and B 0.6 and 0.2, A given B is 0.1. Find the probability that both events occur. Well, our given probability, so that's the probability of A and given B, equals the probability of A and B divided by the probability of B. So there's our definition. So we can now plug in what we know. Probability of A given B is 0.1. We don't know that top part, but we know the probability of B is 0.2. So if we solve this, let's see, times 0.2 times 0.2, we have 0.02 equals X, which is the probability of A and B. So the probability of A and B is 0.02. Okay, so now what we could do is we could draw a Venn diagram with this information. So let's see here. We have A and B. So this is 0.02. Probability of A, so that would be 0.58. And B was 0.2, so 0.18. And then let's see, if we add those together, let's see, that's 0.6, 0.18, 0.78. So that leaves 0.22 for the outside. So at least one of the events occurs. So 0.58 plus 0.02 plus 0.18. So we have 0.78. Exactly one occurs, so 0.58 plus 0.18. So that is 0.76. B occurs given that A occurs. So we want the probability of B given A. So that's the probability of B and A over the probability of A. So this would be 0.02 over 0.6, which is 0.03 repeating. So Jack does 3/5 of the job around the house and Jill does the rest. If 35% of Jack's jobs are finished properly and 55% of Jill's are finished properly, find the probability that a job around the house will be done properly. So I'm going to make a Venn diagram here. We have Jack and Jill. So 3/5. So that means Jill does 2/5. And then properly. So I'm going to put properly, not properly. Properly, not properly done. If 35% of Jack's jobs are finished properly, so 0.35. Not properly would be 0.65. 55% of Jill, so 0.55, 0.45. Well, we could multiply these together and find each probability. So this would be 0.21, 0.39, let's see, 2/5 times 0.55, 0.22, 2/5 times 0.45, 0.18. Okay, and now let's see. So find the probability that a job done around the house is done properly. So we have this branch and that branch. So 0.21 plus 0.22 equals 0.43. If it was done by Jill, it was done properly. So if it was done by Jill, it was not done properly. So the probability of not proper given Jill. Well, so that's our probability of not proper and Jill over the probability of Jill. So not proper and Jill. So that's right down here. So that's 0.18. But the probability of Jill would be those two. So that would be... Oh, whoops, I think I messed this up. I missed the wording on this one. Sorry about that. You want the probability that it was by Jill given it was not done properly. So that changes it a little bit. The probability of Jill and not proper given the probability of not proper. So, yeah, by Jill, so we want that if it was done not properly. So Jill and not proper, so that's still this one, 0.18. But the probability of not proper, if we take a look for that, not proper, we have here and here. I don't know why I put a 1 there. So we have 0.18 plus 0.39, so 0.18 over 0.57. So we could say 18 over 57.